Okay, so let's start. So remember we did the, well, first, do you have any questions about the homework, the 2D aneurysm, the YouTube tutorials that you have to follow?
What are the 3D objects that we're supposed to draw or make?
Can you repeat it?
There's the homework says to do 2 3D.
The 3D objects, yes.
What objects are they?
The first object is in the first YouTube video.
Okay.
And the second object is in the second YouTube video. So let me show you that.
The PDF tutorial for the aneurysm and the 2 videos for the 2.
Yeah, yeah. So one object, one 3D object will come from this, right? And the other 3D object will come from this one. Okay. Any questions? Any other questions? Okay, so what we will do in this class is try to give it a try to see if we can do this in 3D. Yeah, 2D is a big assumption. The flow one behaves as it's supposed to be. So that will be part of your homework for the next week. Actually, you have to submit homework too this Wednesday. So the Wednesday after that, you will have to do a 3D aneurysm. And also another 3D geometry. So we will try to do the simulation. We will do the simulation of heat sink that is being cooled with liquid. Okay, so it's a 3D geometry, and we will try to do that. And so for the homework next week, it's just the 2D aneurysm with 2 simple 3D objects. For the homework after that week will be the 3D aneurysm. You will have to do the simulation, but then we will do the simulation for a heat sink, 3D heat sink being cooled with liquid. Okay. So how to go ahead and do the 3D simulation? So let's try to show that in this the 3D object in this class. This will become a cylinder, right? This one's also cylinder, so they should have a curvature. And then this one will be some kind of a 3D sphere. So if you did the tutorials, then this will be easier. Also, I strongly suggest you to go through this SpaceClaim Tutorials. Right? They will make a whole difference. I just spent 1 hour going through these tutorials. I know it was boring, but just watching, learn the basic tools in SpaceClaim, and then your life will be much easier, and you will be able to do the homework easily. But if you don't watch these tutorials, you will be struggling in SpaceClaim, how to do this, how to do that. Also, download the tutorials, download the videos, and include them in your folder, right? In your library. I told you at the beginning that it's important to create your own library. So download these videos and put them in your CFD folder, and then add a subfolder, add a folder inside that folder that would say week 3 3D objects. And then inside that folder, put another folder that will say SpaceClaim Tutorials Essentials. And then you put all these videos in there. So when you are trying to do the 3D geometry, and then you are trying to think how to do a certain thing, how to do a pool, or how to move the object, then you will have, the only thing that you have to do is go and watch the video that is right there on your folder. And the video will remind you how to do that. So it will be simpler, right? So just do that. It's very important that you create your own library. And who knows, maybe 3 years from now, you will be asked to do a 3D simulation. So it will be easier just to go to your folder, see the examples that you did, see how you did that, and then take that as a reference. Okay, so now let's work on this. So let's open SpaceClaim. So I will open it. You may want to do it yourself or not. So you decide what's better for you. If you want to watch only, that's fine. So what we need to do is open, what is it, Workbench, right? ANSYS, so ANSYS, and then open Workbench. And it's my first time like doing this, so be patient with me. I may make some mistakes. So I prefer to do the tutorials and then you follow the tutorials. So it takes more time. Yeah, you need to install ANSYS in your computer. That's fine. So you can just watch. And also, I'm recording this tutorial, so I will upload the video in my courses. So the first thing is drag. So click on Fluent, and drag it. That will create your project. Now, the second thing is, so we want to create a geometry. It's a 3D geometry. You see that on your on the right side, right? And then, so now click on geometry, and that will open SpaceClaim. Okay, so the first thing we're seeing is a 3D environment, right? So now I created this guideline to do the geometry. So we will divide the geometry into 3 main structures. Structure 1 will be the vertical vessel. Structure 2 will be the horizontal vessel on the right side, on the left side, and structure 3 will be the horizontal vessel on the right side. And then structure 4 will be what the hemispherical aneurysm sac. So for the structure 1, we will do it in 2 simple steps. First, we need to create the reference to the object, right? And that needs to be done in the XY plane. And the reference object consists of an internal circle that has a diameter of 4.4 mm and an external circle that has a diameter of 5 mm. And the center of the circle is located at 0, 0, 0. Right. So, and then the step 2, we will apply the pull tool to the geometry, and then we will create a vertical cylindrical vessel. So let's do that. So first, it is asking us to locate ourselves in the XY plane. So to do that, you click on the, okay, so we're in select. No, so we are already in the XY plane, right? No, XY plane, yeah. So we're in the XY plane, see? So the grid lines are in the XY plane, so we are fine. We don't have to do anything else. So now just create the one circle. So click on the circle, then click at the center. And I forgot the diameter. Let's check for the diameter. The diameter should be 4.4 mm, right? So it's going to be 4.4. Okay, so that created the circle. So now we will create another circle. And this should be 5.0, right? So you type 5.0, and this will be step 1, right? So now step 2 says apply the pull operation, the pull tool. So what we need to do is just click on pull. No, actually, so we're in a 2D environment, so we need to end the sketching. So click on end sketch editing at the top. And now SpaceClaim created a surface from us, right? So from the lines that we did, Now SpaceClaim created the surface. So we don't care about the surface. We will delete it. So click on select, then click on the surface and delete that. So we're done. So now we have a ring. So now let's go to the step 2 and apply the pull operation to this one. So click on pull, click on the ring, and then drag up, right? And now we need to find the dimension of the vertical vessel. And the dimension is 48 mm, okay? So just type 48 mm. Okay, just type 48 and then enter. Oh, that doesn't look like right. Okay, so if that doesn't look right, just do this. So go back again and let's try again. Okay. So select the pool, then select the surface, drag up, and put the 48, and then enter. Okay, that looks better. So now we are done with the first 3D structure, right? So now we need to create the second 3D structure, which will be the left arm. Is that right? Yeah. So the second structure is horizontal vessel on the left side. Now, something that I do, and this is one of the keys on successfully conducting a simulation without too much frustration, is I go step by step. I check step by step that everything will work the way I expect. So if I continue creating objects, then the sphere, then at the end, I may find that something went wrong since the very beginning, right? So to avoid that, we are going to do a step-by-step process. So first, let's see if SpaceClaim is able to create the 3D volume inside this vessel that will allow us to do the simulation, right? Because right now, if I export this to ANSYS will think that we are trying to simulate the solid, right? But no, we are trying to simulate the blood that goes to the vessel. So we need to first extract the volume inside the vessel and then import that into ANSYS. So let's see if that is possible with this simple structure. And if that's possible, then we can go to the next step, which is creating the other vessel. Okay, so to extract the volume is go to prepare, then extract volume. And then see, we need to select it says select faces that enclose the region. You see at the top, select faces that enclose the region. So we need to do that. So now it's tricky to rotate the figure in SpaceClaim. So see, if you do click on the middle button and then move it, it will rotate. Then if you just rotate the spin, the wheel, then it will do zoom. So it's asking us to select these two faces, right? This one, and then control, and then, but first you have to rotate, and then control and left click, right? So now the next thing is go and do click here, which is select seat face. And these are very established steps, right? If you ask me, hey, how do you know it is this and not this and not this? It is because these are very established steps, right? There is I learned this from another tutorial where where it showed me how to extract the volume. So these are kind of very established steps. So now select the seat face and go and then click on the internal face. Don't click on the external. So you click on the internal surface, right? So now after that, then you do click on this button, and then voila, right? We have our object or solid. So now we will be able to extract or import that into ANSYS 20. Okay, so this step is good. You save it. Save design one. Do you want to replace it? Yes. So now we exit the SpaceClaim. So now we will go and do the step number 2. So which will be a little bit more complex because we will have 2 cylinders that are interconnected, right? So what I did is I did right click and then I did duplicate, and that created the B project. And now I do double click in geometry. So see, I go step by step. If you have a very complex simulation, I strongly recommend you to simplify your simulation and then first do the simple step, right? If you are able to do the simple step, then go one step more, a little bit more complex. If you are able to do the little bit more complex thing, then you go more, right? And you continue doing that until you have your complex simulation running. Okay, so what we are going to do is delete this volume. Right? So now we have our vertical vessel, right? So you can also do click on here. So that will give you a 3-metric visualization of your geometry. So now let's check what is the steps to create a structure 2. So it says the vessel has a circular cross section, and consists of 2 circles, but the circles are located in the XY plane. Right? YC plane. And these are the diameters. Okay. And then what else? It has a curve, so the cylinders are not fully horizontal, so they have some kind of curvature. We need to include that. But if you watch this other video, right? If you watch one of these videos, I don't remember which one, that will tell you how to create cylinders that have a certain curvature. So you will need to look into that and then apply that. But let's just create a simple vessel that is horizontal for now and try to merge these 2 vessels together, right? So first, these are the steps. It's asking us to go to the YC plane. So let's do that. So to do that, so these are the axes, right? So if you click on the C axis and then control and click on the Y axis, and then you are indicating SpaceClaim that you want to work on the YC plane. So to finalize that step, what you need to do is go to plane view. Go to plane view. So go to sketch view. Where is that one? Sketch mode. So click on design and then go to sketch mode. So now we are in the YC plane, right? So, okay. And I don't like this cylinder a lot because I extruded into the Y positive direction. I should have done it into the Y negative direction. So my origin would have been located here, right? But that's okay. We can just try with this one, or we can just correct this one. Yeah, let's try with this one. Yeah. Okay. So now what we need to do is work on this one and put a circle in there. So we're in the YC plane, right? Yeah. Both circles are in the YC plane and have this diameter. Okay, so now let's put this first circle. And it says that it should have a diameter of Actually, it should have the same diameter as the first vessel, right? Otherwise, it won't work. So it was 4.4. Yeah. So type 4.4 to see how the vessel will have the same diameter as the other vessel. So make sure that that's the case. Otherwise, your 3D model won't be able to merge properly. So now click on the circle and now type the other diameter, which is 5.0. Okay. So now we did this. So we are done with what? Step 1. Right. So now let's just apply the pull operation. Right now we are not concerned about the curvature of the cylinders. So let's worry about that later. So we are done with the sketching in 2D. So click on the end sketching. And now we have these two, see? So now we don't care about this one. So just click on select, click on the surface and delete. Now we are fine. Right, so now we need to extrude. Actually, you can click on spin, see, right here. So click on spin and now you can rotate your figure. So now what we need to do is extrude the cylinder into the X direction. That will create our horizontal vessels. So to do that, apply, so click on pull, then select your surface that you want to extrude. Oops. Just be ensure that this surface is not one of the edges, right? So make sure that you select the surface. If you do only one of the edges, then it won't work. So the next thing is, see this window here on the, what will be on your left side? Click on add. That will tell the software that we want to add material and not to put. And also click on pull both sides. So we will do both sides at the same time. And then also no merge, because we don't want SpaceClaim to merge these objects. So we want two different solids for now. One solid for the vertical vessel, one solid for the horizontal vessel. Right. So no merge, and then drag and see. Now SpaceClaim is doing our horizontal vessels. So what we can do here is just put a length, a random length for now of, let's see, 40, and do enter. So now go to sketch, go to design, click on the spin, and see, now we have this thing here. But guess what? The horizontal vessel is not clear, right? It has this kind of obstruction that we need to remove. So these two objects are not merged, actually. So click on escape, see? So we need to remove that obstruction of the horizontal vessel, right? And so to do that, and all these steps are explained in here, right? In here. Of course, they are not doing an aneurysm, but they are doing a different thing. But yeah, if you want to understand more about these steps and what other options do you have, just go through this tutorial. So now, how to merge these two properly? So click on combine. So we are in design, click on combine. And then see, it's saying click a target object. Right. So what object do you want to combine? Or what we want to do is cut this part, right? Or see, actually, what we need to do, see, if I uncheck this solid, now I am able to see only the vertical vessel. If I check this, and I uncheck this, I am able to see the horizontal vessel, right? So see, if I rotate the horizontal vessel, it doesn't have a hole. So if blood flow is coming through the vertical vessel, it will face this wall, right? And flow won't go through the horizontal vessel. So actually, we need to cut that part of the horizontal vessel. So to do that, so just click on combine, and then select your target object will be the horizontal vessel, and then click on cutter, right? So what do you want to cut is asking. So I want to cut the intersection between these two guys. So click on the vertical one, and then see what happens. It's asking, so SpaceClaim created more solids for you, right? So it created this solid, the pink one. Then it created this other solid for you. Then it created this other solid. And then it created this other solid, right? So what we need to do is remove the intersection, right? We want to open the horizontal vessel. So to do that, just let's see which solid is the vertical vessel and check that, right? So now we want to remove this one. So just click on that one and voila, right? Now we have an open horizontal vessel, right? So now, yes, to click on scale, but guess what? If we look at still, right, we are done with the horizontal, but the vertical is still there, right? It's not good. So if we want to apply the same technique and cut this part, so it won't work. See, if you do click here, then click on the vertical vessel, and then click on the cutter and select the other one because it's the intersection. So you want to remove the intersection. See, if SpaceClaim will tell you unable to intersect the bodies. And that's because you don't longer have a surface that is intersecting that body, right? We remove that surface. So what we need to do instead of doing that is go to split body. So on the left, on the top, click on split. And then select your, it says, click a target object. So our target object will be this one. And then click a face, plane, or an edge where the volume will be split, right? So click on the internal face of your horizontal cylinder. And now see, now SpaceClaim created different objects for us. And it's asking us, do you want to delete any of the objects that I created? So it created this object for us and also this object. So it's asking us, do you want to delete one? Yes, I want to delete this one. You want to delete another one? Yes, I want to delete this one too. Okay. Do you want to delete? No. Okay. So now scale. And now see what's going on. The horizontal vessel is clear. Blood can go through it, not a problem. And also, if you look at the vertical vessel, it's also clear, right? So we can even play with these marks on the left side, right? So if you uncheck the horizontal vessel, see, now your vertical vessel is open. And if you check your horizontal vessel and uncheck your vertical vessel, now you see it's also open. So that's good, right? But the thing is, we are done with this basic step. Can we extract a volume out of this complex geometry, right? Because again, if you transfer this to ANSYS will think that you want to model heat transfer on the solid, right? But we don't want to model heat transfer on the solid. We want to model blood flow going through the volumes, right? So we need to extract the internal volume and pass that to ANSYS point. So can we extract the volume in this more complicated geometry? And if we can, then we are done with this step, and then we can move to another more complex step, which will be creating the hemispherical geometry. So let's check that. Go to prepare, extract volume, and then it says select your faces that enclose the region, right? So click on this face, then rotate. So it's middle bottom and then move it. That will rotate your geometry. Then control, click on this face. Now rotate, then control, click on this face. Right, so that we're done with selecting the faces that enclose the region. So now what we will do is select the seed face, right? So remember to select the internal face, don't select the external. And we only need to select one. We don't have to select all the three, right? So only the one in the vertical vessel and the interior. And then click on check to complete. And see, now we have a volume, right? So ANSYS SpaceClaim created this nice volume for us. Now we can simulate blood going through this T, right? Yeah. And this is what we want, right? So we are done with this step. So now let's increase the level of complexity. So save this file, exit, and then right click, and then duplicate. And now we have this, right? This is also helpful in case you made a mistake creating the hemispherical geometry, the aneurysm set. You can just close your SpaceClaim and delete this project and start from here, right? You don't have to start from zero, right? That's also another relevant factor of doing things step by step, right? If you do something wrong in this part, just close it, delete it, and then duplicate this one, and you don't have to start from zero, right? And of course, we are doing a very simple geometry, but imagine in industry, you will be dealing with very complex objects. So you don't want to spend all week working on something, then you do a mistake, and then you have to start from zero. So now double click in geometry. Starting SpaceClaim, it says at the bottom. So now check your objects and delete the volume. So right click and then delete. Right. So now we have this. The next thing is to create a hemispherical geometry on the top. And I won't be able to show you how to get the curvature, but if you want if you watch the YouTube videos, they will show you how to make this instead of making them horizontal, add like a curvature and then extrude you cylinder through that curvature. So instead of being horizontal, it will look like this or like this, right? So that's for you to practice, right? So now let's go to the next step, which is create a structure tree, which corresponds. Oh no, we're done with this because we did the left and right at the same time. But when you do the actual shape, you won't be able to do both at the same time. So you will have to first do the left side and do the right side because they have different curvatures. So now we want to go and create the structure number 4, which corresponds to the aneurysm sac, including a neck. And the neck thing is kind of not easy to do, but yeah, let's try. So first, it says step 1, create a 2D object, consists of 2 semicircles. and the center is located at this point. The neck is connected to the semicircles and this, right? The important thing here is the 2D object is located at the XY plane. So let's select the XY plane. So after we created the 2D object, we will rotate the object and create the hemispherical thing. Okay. So let's tell SpaceClaim that we need to work on the XC plane, no, on the XY plane. So SpaceClaim, please allow us to work on the XY plane. So to do that, just click on the X control, click on the Y, then go to design, and then go to sketch mode. And now SpaceClaim created this thing for us. So now click on this 3 metric, and then click on plane view. So now we are there. It's from downwards, right? So yeah. So now let's just create a circle. So we create a circle of the Aneurysm sac, and it should have a diameter of 17 mm. And the center of the circle should be located. So to specify the center, just click on dimension. Then click on the point of the center of the circle. And then click on the x-axis. Right? And this one should be at 9.5. Okay. So now we will create another circle just to have the thickness of the Aneurysm sac. Just make sure that it selects the point. So click on the center. And this one should be 17.6. Right? So looks like we are almost there. But since we are going to rotate along the y-axis, we don't need this thing. So we need to trim this part and then do the rotation only with this part. So to trim this geometry, first we need to create a line that will allow us to trim. So click on the top, click on the bottom. So now we created the line where we will trim our edges. So now click on the trim away T at the top. You see, trim, and then select the edges that you don't want to see. Okay. So now we still need to close this. So click on this one and delete. See, these are open, so we need to close them. So click on line, click at the top, click at the bottom. Now do the same for the other points at the top. So click on design, no, sketch, line, top point, bottom point, and then we are done. Right. So now we need to also tell SpaceClaim or axis that our axis of rotation is the Y plane. So for that, we need to create this line again. So we will use that line to tell SpaceClaim that that's of axis of rotation. So SpaceClaim created this line, this extra line for me, and we'll just delete it. So we are all set to rotate our surface and create the Aneurysm sac. So click on End Sketch, Editing, and see it created this surface, but we don't like the one at the center. So click on that one, just delete that. and it also deleted the, see, it deleted the axis. That will do it. Let's try with that one. Okay, so now click on pull. So we are going to rotate, right? Click on pull, click on your surface, and then revolve. And it's asking you for an axis to revolve. I tried that, no, it doesn't work. Let's see. Well, it looks like, yeah. I'm trying. Okay, let's try use this one and see if it works. And then click on full pull. And yes, it did it. Oh, we're lucky. Then see, it created this surface for us. Then escape. Okay. So we are done. But the issue here is, if you look at the interior, there is this. Okay, let me just move this fan. Move. You see, it's not open. So we are having the same issue. Blood won't be able to go inside the aneurysm sac. So what we need to do is combine these geometries, right? So, oh, and we also did another mistake. We forgot to indicate that we don't want to merge the two objects, right? So see, SpaceClaim created one object, and it should have created one object for the sphere, another object for the arms, right? So, but don't worry, we just do back at the top and see. Now it took us back to our previous step. So now let's repeat this. Do escape, select pull, and then select your surface. And then revolve. But first, here, click on add, and then click on no merge. Okay, click on no merge. Then click on revolve axis. Then click on your axis. Make sure that no merge is selected. And then click on full pull. And see, now these solids are separated. They are not together into a single one. So now escape. And now we can merge them, right? So to do that, click on combine. Then click on your object that you want to modify or cut. So we want to remove the surface on the horizontal cylinder to be able to open it and allow blood go into the aneurysm sac. So then click on the cutter and then select the intersection geometry. So select this geometry. And now it's asking you which one do you want to delete. So let's see which one is the sphere. So unselect this sphere. And now, yes, we want to delete this pink one, right? So now escape and see, now our horizontal vessel is open, but still the aneurysm sac is still closed, right? So to remove that, what we should do is go and split body. Select the body that you want to split and select the surface where you want to split it, right? So select the internal surface. And then it's asking you, which one do you want to delete? I want to delete this one. Now escape, and we are done, right? So now let's check if this can be prepared, right? Extract the solid. So click on prepare, click on extract volume, and click on your faces. faces that enclose your region. So click on this one, control, well, first rotate, then control, left click, rotate, control, left click. So we are done with selecting our enclosed spaces, and now select your seat face, will be this one, the interior one, remember, and then click on complete. And guess what? We have our aneurysm thing. This is the volume that we will import into ANSYS Fluent to be able to simulate blood going through the vessel, going inside, and then the horizontal vessel, right? So this is the idea. For your homework, of course, you will have to create the curvature, and if possible, add a neck here, because this one, it has a neck, but it's not that clear, right? So just think on how to do that. Put the curvatures. To add the curvature, you just have to watch the YouTube videos, and they will show you how to do that. Okay? So that's it. Thank you. Any questions? And save. Have a nice weekend.